Every hour, the sun sends enough energy to Earth to power all of human civilization for an entire year. We capture about 0.02% of it, but the fact that we capture any of it is the interesting part. Because a solar panel has no moving parts, no fuel, no fire. Solar panels absorb light and make electricity, but flip it around. Feed them electricity, and they start making light. It's basically UV light you can't even see. Today, we're going to understand exactly how that happens. It starts with atoms. Everything around you is made of atoms. Each atom has a center called the nucleus, and electrons orbiting around it. Think of electrons like planets orbiting the sun. Now, most atoms hold on to their electrons very tightly. The electrons stay in orbit, and nothing much happens. But silicon is different. Silicon is the main ingredient in a solar panel. Silicon holds its electrons just loosely enough that if you hit them with the right kind of energy, they actually break free and start moving. And here is the most important thing in this entire video. Moving electrons is electricity. That is literally the definition. Electricity is just electrons moving in a direction. Nothing more complicated than that. So sunlight hits the silicon. Electrons break free and start moving. We have electricity. Except not quite, because those electrons don't move in one direction. They scatter randomly in every direction at once. Left, right, up, down, complete chaos. And random movement in all directions cancels itself out. No useful electricity comes out. So engineers had a problem. How do you force all those electrons to move in the same direction? The answer is the p-n junction. This is the actual genius of a solar panel. Here's how it works. You take your silicon and split it into 2 layers. Then you modify each layer slightly by mixing in a tiny amount of another element. This process is called doping. Yes, really. The top layer gets mixed with phosphorus. Phosphorus brings 1 extra electron with it, so the top layer ends up with a small surplus of electrons. This is called n-type silicon. The bottom layer gets mixed with boron. Boron is missing 1 electron, so the bottom layer ends up with gaps where electrons should be. These gaps are called holes. This is called p-type silicon. Now when you press these 2 layers together, something automatic happens at the boundary between them. The extra electrons from the top layer drift across and fill the holes in the bottom layer. This creates a very thin zone right at the junction where everything is balanced and nothing moves freely anymore. Think of this electric field like a slope on a hill. Anything that rolls onto that slope goes in one direction, whether it wants to or not. Now when sunlight hits the panel, photons knock electrons loose from the silicon atoms. Those free electrons hit the electric field at the junction and get pushed in one direction. All of them. Same direction, every time. That directed movement is your usable electricity. Metal contacts on the front and back of the panel collect these electrons and send them through a wire. Connect that wire to your home, and the electrons flow through your lights, your appliances, your devices. Then they return back to the panel, and the whole cycle repeats, continuously, silently, with no moving parts, for 25 to 30 years. Standard solar panels today convert about 20% of sunlight into electricity. Engineers are working to push that higher, but even at 20%, it is enough to power homes, entire neighborhoods, entire cities.